hear this. Okay, great. So just to say again, welcome to AME 494. It's also a complex adaptive systems course on alternate ecologies and economies, alter eco for short. It's easier to say. I've done a version of this seminar before as a seminar in previous years, but this is the first time trying it online. Welcome, Christopher. So it's the first time trying it online versus in person and in some particular seminars that have been held in previous years. So the materials that I'm sharing with you all have been field tested in a way, but they're also new materials. There's new content too. And so there's two parts to this course. The first part, kind of the general part, is alternate ecologies and economies. Of course, that's too big. Okay, it's really gigantic. But that was the motivation. The motivation was to say, okay, look, if we're living in these times of, let's say, civilization challenging change, whether it's climate change or unknown unknowns, how can we best position prepare ourselves to work effectively in whatever domains we're working in? Okay, whether it's artists or as activists or as systems designers or any field, or simply as parents, in a way that's both informed and agile. Okay, now this particular course has a colon infrastructures, and even that's very big. Okay, but more specializing to this case of looking at infrastructures. Why infrastructures? Well, I'm sure I'm not going to ask you all to say again, why, how you come into this course and what you bring to this course, what questions you bring to this course, why you're doing it. But one of the motivations for looking at infrastructures is that if we look at questions like climate change or whatever, it's easy to dive right into a specific problem. It could be food security, for example. I mean, that's very basic too. But whatever the problems are, they're always tangled up with other problems too, right? That's the whole notion of a wicked, messy problem, right? That you can't easily dissect and pull it apart and just look at one problem in isolation. So infrastructure has this quality where it's kind of like sitting underneath everything, right? That's what's called infrastructure. And we'll talk about that today too, what we mean by that. But that was a motivation for looking at infrastructure rather than one isolated problem, just one isolated problem. Anyway, so since we have four of us here, maybe we can start by doing some introductions. And I know you've written some introductions already. That's assignment 0. That's easy. So maybe you can share where you're coming from and what brought you to this course and what you're interested in thinking about with respect to the course, but also beyond. Why don't we just start with you, Tanya?
Okay. My name is Tanya. I used to be in finance for a number of years. I ran my own company, and I took a sabbatical and went back to school. I graduated in GIS when I did that at Ohio State in 2 years ago. So I got my bachelor's in GIS. I also studied statistics and city and regional planning. So I had 2 minors along with that. And since then, I decided to take up a master's program in complex adaptive system science at Arizona State. I'm extremely interested in, this first kind of set of readings is really in my wheelhouse in terms of thinking about urban systems and how that impacts, the lives of people and the health of communities. So I'm super excited about this class, for real.
Great. Welcome. Great. And are you in the first year? I guess you're in the first year of the.
No, I am. I will probably graduate this spring as long as I can get my project done. This will put me. I have all my hours in. So.
Okay. Cool. Welcome. Glad to meet you.
Thank you.
GIS is Geographic Information Systems.
Yes. Yeah, geographic information science. Yeah, spatial. I'm really interested in spatial thinking, spatial statistics, and modeling, that kind of thing. Yeah.
Super cool. All right, great. Chieko.
Yeah. So my name is Chieko. I'm currently majoring in informatics. It's kind of a new degree at ASU. It's a combination of computer science and data visualization. And this is actually my second bout at ASU. I initially graduated with a bachelor's in Japanese and Korean studies back in 2018, where I also had the opportunity to live in Japan for a couple of years. So that was really insightful as far as like learning about new cultures and whatnot. Right now, I am working with a small startup company that uses Web3 technology or blockchain technology to kind of help combine disparate companies so that they can better reconcile transactions and whatnot. And having that insight into distributed ledger technology has really opened my eyes to a lot of what's lacking in our current systems as far as like the stop and go and check and the checks and balances. So that's my huge draw to this course is seeing how we can kind of re-examine infrastructure and improve in those areas.
Super. Very cool. Thank you. Let's do an order of appearance. How about that? So that means Chris or Christopher, you're up next. And if you don't mind, I'm going to see you in video. Don't mind the bandwidth. There are only 5 of us, but it's up to you. Chris?
Hi, can you hear me?
Yes.
Sorry, I would turn on my webcam if I had one. I already ordered one. My PC doesn't have one. I'm so sorry. Uh, Probably for next time I'll be able to turn on. But hi, I'm Christopher. This is my second semester at ASU. I major in graphic information technology, which is like a mix of computer science and like art. Um, the reason why I joined this class is because I want to have a better understanding of it, like of infrastructure in general. And um, I'm more because I've joined a club that talks like stuff about it similar and how I just don't know enough about infrastructure and I would like to expand my knowledge on that. So this is us. Yeah, I'm sorry, but yeah.
Super. Hey, Christopher. Sorry, I should say Christopher. Um, uh, what's the club, by the way? It's an AME related club, or what's the club?
It's YDSA. It's Young Democratic Socialist of America.
Mhm.
So yeah.
Cool. Great. So that'd be very cool. I'm glad you brought that you're bringing your interest to this course as well, and welcome to you. Leaky, it's good to see you again.
Yes, thank you. It's nice to be here. Apologies for joining late. I'm just joining in from another class. I guess the question is what we're doing here and what's our background, because I missed that.
Yes, we're just introducing ourselves and exactly and what brings you to this course.
Okay. Okay, so my name is Bemileke, second year media arts and sciences, master student here at ASU. I'm from Nigeria. And so studying at ASU means that I get to live in 2 worlds. So I spent the summer back home in Lagos. And then I'm back here again. And just reading through the readings for this week made me think about the difference. Like I noticed the infrastructural difference between Lagos and Tempe or Phoenix in general. But in addition to that, I'm curious to see how we can reimagine the world that we live in. I think about certain scenarios and I'm like, surely there's a better way to do this. There has to be a better solution. If we come together, we can do things better. So yeah, that's why I'm here. My background is in computer science. I ironically never worked with that degree because after my bachelor's in computer science, I actually proceeded to work in communications in finance. So that also introduces the alternate economies part and another interest of mine for this course. So that's why I'm here.
Super. We have a really fantastic set of backgrounds already and interests. Oh, right, me. I teach in the School of Arts, Media, and Engineering. I'm a professor there. Also in the School of Complex Adaptive Systems. So that's why I formed this course in order to hopefully to appeal to folks from a broader spectrum of interest. So people who are, of course, interested in systems, we should talk about what that means too. All the complexities, mechanical systems, IT systems, yes, but also living systems, biological systems, ecologies. And also social systems, like language, literature, let's say, culture, cities, things like that. So, and they're all quite different, and they have different characteristics and how they intersect. It all proliferates in a rich way. But my background is in mathematics, so my degrees were in mathematics, and I have a long circuitous history. It takes too much time to describe, but I've been teaching in design and arts for a long time, but also in computer science. So between arts and computer science, in terms of the practical parts, what do we make? We can make art, we can make installations, we can make performances, working with theater and dance, right? But also making stuff with engineers coming from mostly computer science and electrical engineering, signal processing, how to take data coming from sensors and use that data, interpret the data, and then use that to parameterize computational systems that can vary our built environment, whether it's projecting images somewhere, or putting out sound fields, okay, or even moving things, mechatronic things, okay, so the built environment. I've been applying with the Synthesis Center. I'm the director also of the Synthesis Center at ASU, applying these kinds of techniques and research to think about working with people in architecture, people in time-based media industries, video, but also with people more recently in, for example, United Nations Development Fund, working with policy people who want to make tools for representing complex systems. So these different ways of representing a complex system, and in addition to representing complex system, how to, like a city is a complex system, okay, and also how to give people the tools to change how those systems are working. All right, we'll be talking about what those systems could be, right? And usually we think of these in just the kind of the utility framework, like how much energy does it take to represent or manipulate the system, or how much money does it take, or how much time does it take in minimizing cost, minimizing time, et cetera. But there are other aspects too, which I hope we will get to this semester, which has to do with social aspects, like, or why are we doing it this way versus that way? Do we want, even if a system works for us, do we want to live with that system? Is it something that we desire, that the people we're building it with or for, would people want to live with that kind of system, not just today, but for generations, things like that. So that actually brings us to our readings today, in fact, too. I mean, we see, I put just a scattering of a few essays here. They're by no means representative. They just start the ball rolling. Oh, Aiden, welcome. Perfect timing. Because we're just introducing, and now since you're here on board, I can ask you, pass the baton to you, Aiden. We're just introducing ourselves. And maybe if you can hear us now, maybe you can just introduce yourself, say a little bit about where you're coming from, what brought you to this course.
Okay.
And we can get started with our discussions, please.
I'm not early, right? I was
No,
3:50. Okay, cool. I thought I was
fine.
early for the next session. Cool. I'm Aiden. I am a senior in media arts and sciences, and you said why I decided to take the course.
Yep.
Well, I had you last year for 20-second hits, that class, and I enjoyed that, so I thought I might as well just take another one of your classes. This one sounded interesting. I don't know, my dad's a construction management Yeah, that's what his degree's in. So I have a little bit of, he did tech theater for high school
Mhm.
at Brophy. So I've been in the infrastructure-ish area, all that stuff for a bit. So yeah, this first unit's pretty interesting.
Okay, welcome aboard. It's good to see you back. So just to come back full circle to what I was saying at the beginning of the hour, these are weekly discussions. You're welcome to attend any that you can attend. Um, so, and right now they're set for 3 o'clock and today and for 9 o'clock, 9 a.m. tomorrow, Wednesday, weekly. I'll try to set up some office hours too for those who can't make either of these two sessions. Really what they're about is for us to talk about the readings and the themes of the week. And that'll help prepare people to write your own, for you to write your own personal reflections on the readings in response to the questions that are in the assignments for the week. Okay, and the pattern is pretty simple. A bit about mechanics. Basically, the modules are lining up week by week. Okay, so every week there's a bunch of readings. There's also a fairly unsurprising question, hopefully, that goes with it. You can do all that work in the Canvas. Just type in your responses. Okay, I'm also structuring it so that it's discussion based, so that you all can see each other's responses, and that's part of the value of this class, I hope. Aside from those kind of weekly responses, which should be like a page or two. Okay. At the end, toward the end of the semester, what I'm hoping we will be able to do is we have about 20 or 19 folks. It's not too big, we're not too small. We'll begin to integrate these different perspectives on ways to approach infrastructure alongside some case studies, meaning types of infrastructures, and hopefully begin to maybe draw that together to do a kind of a study of some complex social technical system that we might try to do a makeover. Last year, in one of my classes, we chose to do a makeover on Arizona State University itself. And that turned out to be pretty productive because we could choose all sorts of things, but then if we choose a city that only 1 or 2 people have lived in, it's kind of difficult. It needs to be something which I think needs to be some system that's real, that has enough complexity, so not a toy, it's not a game, or easily modeled by a game. It has to be something really rich, has some history to it, and some scale. So, but also has to be something that we're all familiar with. So that's what it came to. I'm open to another type of object that we can tinker with and think about. Right now, it's tentatively set to be ASU as our makeover object, okay? But you can think about it that way. Okay, let's start with just this thing about infrastructure or system, system and infrastructure, and hear what you have to say. I mean, when we say, there are 2 different words, okay? When we say system and we say infrastructure, of course they're related, but maybe I can open the floor and hear what you have to say. When we say system, what do you think we mean first? And then we'll get to infrastructure. Let's just say system. People say system all the time. So what do you think we should mean by system? There's no one definition, all right? I'm just put everything on the table. What do you want to mean?
I guess when I think of systems, I think of a combination of moving parts that help support a singular goal. That's right off the bat, off the top of my head. Opposed to infrastructure. Well, I'll leave it at that, and I'll see what.
Give that. I keep going. I'm going to type up notes. Hey, everybody. Here's the thing. I'm just gonna let's all type into the chat, okay? As somebody's talking, other people can type, so we can sort of take turns writing notes for each other. All right. And so I just type it out. So parts supporting a goal. Okay, what else?
When I think of a system, I think of something that you can conceptualize as a single thing, but that is also not a single thing. So it's made up of parts that are working together to create something you think of as a whole. but you can look at it and see that it's like, it's something that you can break down further and see that it's not just a single thing.
Yeah.
But it's also not just the parts working together. It's the parts working together, but they also create there's like a boundary to it, right? Yeah.
Something that's, there's an inside and outside to the system. This thing, it's a thing that's sharply, well, usually it's bounded. So it's distinct from kind of the outside. Okay. What else? What are the characteristics? Like what's not a system? Like suppose we have a bunch of parts, all right, and we can think really concretely. Like we say a car, okay, a car. Um, a car is a machine. Okay, fine. So would you say that normally when we say system, we think of something as compact as a toaster or a car, or something more than that? And what? Why?
I think systems can vary in complexity and also in context. So I think given your examples, I would say that a car is a mechanical system. And it can also function as a subsystem. So for instance, the car is a subsystem in the greater transportation system. So I think context matters as well. And a system, context and complexity are two things that systems have.
I can't talk and type at the same time. So you guys, you have the baton. Normally when we say car, when I say car, I don't think of the car as a system, but then when you say, take the context of thinking as a mechanical system and say, yeah, it makes sense, bang, fine. But why is it that normally when I say car, I don't think of it as a system? Why? I don't know. I mean, something about it. I think I say transportation system, right? And then it has cars in it, has roads, has stop signs, it has da 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 da. We can flesh it out.
Perhaps it's the exposure of the components. So when you think of a car, you think of just the object itself and it's outside. But if you define like a transportation system, what immediately comes to mind is the inside parts of what makes up that transportation system. Whereas if I were to say like a car, the engine or what makes up the inside of the car that runs it, then maybe that would bring to mind the imagery of like a system instead.
Which is where context comes in, right? Because I'm not a mechanic. I don't know. I drive a car, but I don't fix my cars. I don't build my own cars. So I do see it as a black box. But if you're thinking as a mechanical engineer or whatever, as an engineer of some sort, then yes, it can be legible to you. So you see the parts, you see the relationships. So that's interesting. Okay. All right. Now, what about infrastructure? If you say infrastructure, it's more or less. I don't know, it's more. So what would you like it to mean? What are some hallmarks?
I think the infrastructure is like the platform. And we said that a system has a boundary. I feel like the infrastructure sets that boundary, creates that boundary.
Say more about what you mean by sets a boundary.
So, for instance, if we're going to talk about a transportation system, then we're talking about something that is moving across roads, train tracks. You don't think of the transportation system as people moving across space openly, right? It's bounded by the ways that we've set down a path for that movement to happen.
Like structure. Yeah.
Good.
I think of infrastructure as a framework. When doing like UI UX design, let's say there's this step in the entire process where you have to make a wireframe. And the wireframe is kind of like a skeletal structure of what it is that you're designing. So that then holds in some ways everything else. So it's not quite the foundation, but I think framework is the best way I can put it.
Since I think I'm assuming all of us on this call have enough background. Let's use software as an example then. Let's just take software development as an example to carry on what you're saying, what Vicky is saying. Because we have this idea of an application, an app that an app programmer, app developer creates. We have this idea of the programming environment, like Xcode, let's say, in which the programmer develops the app. Now, Xcode is also an application. It's just a very large, complicated one to make applications. We have the notion of the language in which the app is written, let's say, like Swift or whatever. We also have the notion of the operating system, right, in which the Xcode application development, the IDE, is running. We have the hardware, the network, right, in which this computer is plugged into, right? It may be Xcode, maybe the IDE is delivered from the cloud, maybe delivered by cloud service. Okay, so let's just take these layers of technology. Where would be the infrastructure in this picture? Infrastructure is plural with an S.
It's the hardware. That's what I would call infrastructure. Like, I wouldn't call the other things you said the infrastructure. I guess maybe the internet too.
Infrastructure.
Yeah.
Yeah. Depends on your point of view, right? Clearly, it is a point of view thing. Suppose I'm an iOS app developer. I create games on a phone, you know. So or I'm a web developer. I develop web pages, and or I'm a web designer. I'm not a coder. I'm a designer, right? So from that point of view, these other layers put underneath me, you know, some of them might appear more infrastructure to me. Like I don't, maybe if I'm a web designer but not a coder, I don't think about, I don't even know like back end, front end distinctions like that. And somebody else takes care of that. It does depend on where you're sitting for sure. The operating system, the OS itself. Let's take the hardware, the internet, and operating system, right? That's what Lake is writing down. How is the OS and how is the network infrastructural? How are they infrastructural?
Well, I would say that they are the basis upon which everything else runs. So for instance, if you have a phone and this is the hardware now and there is no operating system, whatever app you want to use is of no use, because there's nothing to load that app into. And the operating system then presents the structure, the kind of like a container that holds everything else. In the same way, the operating system cannot exist in a vacuum. Can't exist in thin air. So the hardware then serves as the container as well. Then if you apply the same principle to the internet, you most likely can't even access the application. And depending on what phones you're using, you probably can't even load the operating system without the internet in the first place. So in that way, I think they're interconnected, and maybe all equally important to ensure that the phone is usable and functional.
Yeah. And I'm thinking right now, and I mean, we're talking with each other, we're focusing on the Zoom call on each other. I'm not thinking about Wi-Fi. I'm not really thinking about bandwidth until it's a problem. So yes, absolutely, internet is infrastructural. But you know, it's interesting. Paul Edwards, he's one of the four authors.
Yeah.
I printed out black, so it's like really awful to read. But he wrote about it's what is it? The mechanics of invisibility. Invisibility is a keyword. On habit and routine as elements of infrastructure. That's his basic point. That for him, if one of the hallmarks of infrastructure is that it's invisible. It's invisible, or we don't have to pay attention to it in the everyday work.
Yeah. I think it was ignorant because I think that also is differentiating. Not only is it invisible as a, you know, a consequence of being of that working, it's, I think maybe by nature, right? It's that is part of the nature of the infrastructure, is that we're not thinking about it unless it's broken or stops working the way that it was intended.
Absolutely. And even the word itself, I mean, I don't think we should always go to dictionary etymological analysis of terms, but infrastructure, right? It's not called substructure or superstructure, it's infrastructure. So what do you think infra means to us? If you say something, but it's not sub and not super, but it's infra, what does that mean to us? You know,
maybe inside and like subsurface, I guess.
you know, it's woven into, right? Woven into the operations. Because if it's substructure, it's like, oh, in the architecture book, I think in the, maybe it's one of these others, but in the architecture articles, there are two that are more from architecture point of view, and the other two that are dark are more from like a social science point of view. But from the architecture point of view, I think it's one of those articles that was saying that there's a difference between infrastructure from an architect's point of view and foundation. The foundation is the literally what you pour in the ground or you dig into the ground, on top of which you build the house. Okay. Infrastructure for the architects were like what? I can't remember now. Do you remember the examples? I do remember, but I'm asking you. Remember for the architects, what they think of as infrastructure from the point of view of an architect? What are some examples?
The article, the Stelter piece, he talked about differentiation and the specialists that were involved. So that got me thinking a lot about the ideas of like form and function, where architecture is very much involved in the visible, right? What people are directly experiencing, whereas he talked about infrastructure as something that is, you know, that is specialized, and the specialists have needs, you know, they're meeting a particular need, and it's kind of underneath the level of, I mean, I'm not saying this very well, but yeah,
it is. Yeah, I'll try to find it. It's this one, right? Yeah, this one.
Yeah, that was the 8 points on infrastructure. And
Yep. Here. So just 2 pages. It's 4 pages. It's useful.
Yeah.
Here. Okay. So it does not refer to sub or super, right? Blah, blah, blah. We're talking about things that make it permeable to people, the flow of people, flow of goods, of media, energy. We can also add to it flow of data, you know. And that's also the point of the other 2 selections. We're talking about flow. That's in the, let me go.
That's in Weinstock, the system of the flow, the provision of services.
Exactly. Here, this one, right? This, oh no, this is the other one, sorry. I need a bigger screen, sorry. Stop share. It's so much easier in this same space. Weinstock, here we go, thanks, Weinstock. Yeah, this one. And there's a whole, this is from a whole book on system, what's called System City. And I'm looking for the first page here. Infrastructure and the space of flows. And think about what, and you should look at it yourself later on. But flows includes what? Flows of what? What would you say in terms of architecture and design?
Use of space?
Yeah, absolutely. What else? There's
Water.
Just zooming through this.
Electricity?
Energy, electricity. Here it is. There's some diagrams, right? heat. Okay, this is all fine. Okay, this is all the parts that we would think of right off the top of our heads. Okay, now let's since we want to use our time wisely, I want to now really these are the parts we just named rattle off. Okay, but let's now go back to the the two other articles that we want to look at with you, which are the kind of it's called City Beyond Analogy one, which we'll look at last. Okay, but first let's go look at the one by Paul Edwards. Again, the one on invisibility. And if you can look at it with me, just some basic kind of takeaways from him. I was thinking that we might want to capture, but you can tell me. Okay, so in addition to the kind of the mechanics part of infrastructure, flows, electricity, flow of data, flow of people. Okay, so he's adding more to that kind of infrastructure, right? And his examples, I'll just remind you, okay, he's looking at examples of driving on the left side versus the right side of the street. Another was in South Africa using these kind of informal transportation infrastructures, the kind of buses that were basically Toyota vans, you know, not official radio taxis, and finally toilet systems. Okay, but in addition to the kind of mechanics of that, you know, what was he referring to as part of what makes those infrastructure visible or invisible?
Oh, sorry.
Go, please, Christopher.
I was just gonna say, like, humans, or people in general, with, like, I would say, like, without people using the systems, there would be no infrastructure.
And what do people bring? Let's take the examples of driving on the left side versus right side of the road. I mean, in America or North America, we drive on the right side. He's talking about going to South Africa or I guess also in Japan, maybe people driving on the left side of the road, right?
Mhm.
And then, so what makes it like, how he has to learn how to use those ways of driving, the ways to use the infrastructure of the roads.
Yeah, you build the habit and it just becomes what's normal. And that's what also contributes to the invisibility aspect of it is you just live it day by day and it just becomes a part of your daily life that you don't really notice because it is so integrated.
Absolutely. Comes with the people, right? Now, what that enables is, okay, so what else is being normalized when you switch between countries and driving? What do you have to internalize? Some examples. I mean, if you lived in Japan a little bit, I mean, you can tell us, like what else in terms of transportation have to get used to? It's different.
Yeah, I mean, I guess it's just the way how people use those roads. Like, for example, in Japan, a lot more people, at least compared to Arizona, walk or use bicycles. And oftentimes, the way Japanese architecture just evolved was that they didn't have the space for big enough roads. And so a lot of people, pedestrians, bicyclists, and cars all share the same exact road, especially in the more rural areas. So that's definitely something that is very different and something you have to be considerate of.
Yep, that's a very important point. And some of it's explicitly coded, like here, like in Montreal and Phoenix too, I guess there are bike lanes that are painted on the pavement along with norms. Like, you know, do we expect or not expect the bicyclists to be in the middle of the lane? In California, it used to be that the bicyclist had the same legal rights as a car. So the bicyclist was legally allowed to and expected to be in the middle of the lane. Actually, which was, you might think, a stupid or a smart idea. It depends really. But in other cities, they put up bike lanes. But then you get used to it, right? You get used to not looking for the bike in front of you. You get used to looking for bikes on the right side when you make a turn, stuff like that, right? That's part of his point. You internalize these kinds of legal, well, it goes both ways. Internalize these legal codes into habits, but also people's aspirational expectations some of them get formalized right, into these things, both legal and also physical. You paint it. And what was this example of visibility? Um, so he made a certain point about infrastructure being not just the physical part, right?
Yeah, he talked about the social mechanisms. There was like individual choices, but then there were social mechanisms, and that those social mechanisms were part of that infrastructure.
Yep, it makes the infrastructure usable. So there's a personal part, which is I think Jacob you're talking about too. Just think about the habits and skills, like the habit of you know, turning a certain way, looking a certain direction, things like that. It becomes somaticized. So that's a phenomenological, you know, apparatus that you build in order to effectively use infrastructure. The other part is social. Okay, it's kind of social, and then there are these what they call norms, right? But also laws, codes, regulations, and even organizations, like the organizations too. So that's what I think we will be carrying for the rest of the semester. Okay, looking at all these other layers. So that's why people say social technical system. Right? It's not just technical; it's a social technical system, right? And then we think about the social aspects of infrastructure. That's it. Now let's go on to the last thing, which is one to bring up. There's one piece out of the four by this fellow. What's his name? Fournier. It's the City Beyond Analogy. This one here, City Beyond Analogy. So, so he made some pretty strong, like fundamental caveats about this system approach to looking at cities, which is the rest of the volume called System City. So you want to give us a few tidbits from like why or what he was warning us about in his approach, in his balance, his caveat. I'm looking through this myself here, and I can probably share the screen as I do that. First of all, I wonder why he called it an analogy. So let me share the screen with this. Just to give you some background, the whole book is called System City, is from many different points of view, looking at the city with the optical complex adaptive systems. And maybe I should give you a little bit of a snapshot for that. We'd already talked about a system as having, let's say, different components and parts in relation to one another. It could be, the body as a system. You have the cardiovascular system, right? Or you have the lungs and heart and liver system put together, right? Et cetera, et cetera. Or it could be a mechanical system that we've been talking about. But then we think about something which is adapts to a situation. So if we have just a bunch of parts linked together like a Tinkertoy structure, it doesn't adapt. But a living body, sure, it adapts. We walk up the stairs, the heart starts to pump more, et cetera, right? Complex adaptive is more than that, right? This is idea of a looping going on. Like for example, the typical example, I'm going to be quick because we're short on time. Normally we should work this out through examples, more examples from you all, from everyone. But a complex adaptive system where there's some sort of monitoring of the system of itself.
Right.
And then adapting it, right? Maybe you can give some example besides the body. The body does this, but what else can you give as an example of a system that kind of monitors and adapts itself? Other examples?
I mean, you might think of, the way traffic moves in a city as being somewhat adaptive, right? So people do try to avoid being caught up in like a traffic jam, right? Not always terribly successful at that, but so there's so that's somewhat adaptive, I think.
And how do we do that? Just practically.
Yeah, so there is some monitoring, people check in on, there's like there's information systems to like let people know this traffic is bad here, so they choose a different route, and that then implies that there's some knowledge, right, about those options, right? So you can take a different route today,
Absolutely.
and then that's on a short-term basis.
Yeah.
And then long-term, there's like you can add other modes that you didn't have before.
Yeah.
As a matter of policy.
Yeah.
That's very long-term, right?
Yeah. I mean, but also, you know, like just practically speaking, before GPS, before iPhones and before smartphones and GPS, it wasn't so self-referential, right? I mean, we were drivers, we were at the mercy of just we get into a traffic jam that we couldn't have foreseen because we didn't see it. I mean, we only have local knowledge. We only had local knowledge. Ordinary drivers didn't have this kind of God's eye view of that we have now today with GPS, which is very interesting. So yes, I think today, yes, the transportation networks with people in it, drivers in it, is more self-reflexive than before. More, it's true. Interesting. It's interesting that we paused when I asked this question because I'm thinking, oh wow, we were all talking about like technological systems, and it's kind of hard. Oh wow, so how to come up with an example, and then thank you, Tanya came up with actually a very nice example. Whereas if it said, oh, human body, animal, oh yeah, instantly, yeah, sure, they modified their state in response to a perturbation. Yeah, of course. Right. So that tells us something. And we'll come back to that when we read about metabolic and biological systems. All right. It's not easy to make for humans, for us to make a technology that's richly reflexive and adapts itself to perturbations, whereas we see that all the time in life, in living systems, actually. So it's quite interesting. Let's take our last few minutes to look at this article by Colin Fournier. I'll share screen again, but you can look at it yourselves. Because he was really pointing out some ways in which the systems approach actually is inadequate to a city, or at least warning us that there are some things that maybe we better think about. Maybe it's easier to look at it on your own copies than on the screen, but I'm just walking through the pages to give us a little bit of a recap. Let me go back to the second page here. They're too small to look at. There we go. Let's make it bigger. Right. So, for example, right here, it's actually pretty challenging because here he's talking about antithesis, this thing here. That caught my eye when I first read through this thing. Antithesis, to say this whole book is about cities, and systems, thinking of cities as systems and complex adaptive systems, et cetera. And then he was saying, well, this whole, why do we do this? And he was asking, why are we doing this? He said, well, for sustainability, talking about how more and more people will be living in cities now. I think the majority of human beings are living in cities, et cetera, et cetera. And then he was reminding us that actually, well, wait a minute, this is recent. For most of human history, people have not been concentrated in cities. Relatively a minor proportion of human beings were living in cities of that time. So this is a recent phenomenon. And maybe we don't want to just focus only on the phenomena of making cities work better. Maybe cities are part of the problem. All right. So that's one thing. So that's why later on in that paragraph talked about maybe we should look at the whole planetary surface, the whole surface. We should not just only look at urban centers, but consider the whole planet's surface as the region of interest, let's say. Makes sense? So in other words, this nice point here, right, which is that when we're looking at solving a problem, maybe the first thing to think about is the scope of that problem. Are we scoping the problem correctly? Because if we try to just solve the problem as defined, maybe that's actually going to make things worse. Okay, in his case, he's thinking about, well, maybe with all this concentration of resources like waste disposal or heat island effect that we have in Phoenix, right? Heat island is ferocious, right? Even aside from climate change, it may be that trying to just tackle that problem by itself is really, really hard. Right? Improving the infrastructures of the city is really hard, when in fact the concentration is part of the problem. Then we think about energy systems or whatever, food distribution. What would happen if we somehow took the population of Phoenix, I don't know how many millions it is, and thought about maybe placing it differently across the American Southwest? Of course, this is really has all these other issues, right? What would happen to ASU? Actually, we're doing this course right now. It's online. At least one of us, two of us are not in Phoenix. Wait, just as I'm not in Phoenix right now, and I think Tanya's not. Anybody else? Everybody else is in Phoenix? Are y'all in Phoenix? Okay. Anyways,
Yeah.
all right. Well, so we're a distributed course, and ASU is trying to find the right way, with all its online programs to do this. Okay. We don't have a solution yet, but we're trying to accommodate people who are not all co-located. Okay. For some courses, it can work better than for others. Anyway, so decentralization is absolutely something we should consider. All right. I'll give you a funny story from design. This is a true story without proper names because I don't have the source in front of me. Those that maybe one of you can tell me the exact reference. During World War II, one of the big problems was the bombers that are being sent out to do bombing raids over the Axis powers, Germany, had a huge casualty rate. They were being shot down. They were kind of slow and big and easy targets. Okay, so they had to have a lot of fighters around them, et cetera, to support them. So one of the tech team, actually it was a mathematician, engineers and scientists were brought in to study this problem. Had to come up with a way to make these planes more robust against being shot down. So they would take these bombers that were shot full of holes, right? And they would think about like reinforcing those parts of the bombers and looking at maybe rerouting the fuel lines. So maybe they'd be more hidden or whatever they were. Okay. And then there was this mathematician who was brought in to look at this problem. And I think there was a guy, he said, hey, wait a minute. These are the bombers that make it back. So they have holes shot here, right? But we should be thinking about the bombers who don't make it back. The bombers that make it back have holes over here. So we don't want to armor up those places. It's the planes that didn't come back. They probably were shot up in the complementary region of the plane. That's why they're not back. So this is great. He's thinking like a mathematician, actually. Okay, actually. But this is used in design practice to make us think, wait a minute, maybe we shouldn't be solving the problem as posed. We should think about, first of all, what the goal is, bringing more planes back, and then think about maybe reframing the whole question. It's not about making the armor thicker where the holes are, which is what they were doing.
Yeah, that reminds me a lot of I worked in bicycle advocacy and I work in that area a lot. And it's difficult because a lot of people, there's so many people with cars, it's kind of the problem is really big. And there's often the kind of like, okay, we need more lanes, we need more roads, we need more freeways, right? And then the concept that is actually making the problem worse is really difficult for people to wrap their heads around, when what we're asking many, neighborhoods to do is reduce the number of roads, reduce parking, right? But in reality, by adding more and more capacity for cars, we make it just the situation for driving much worse.
Licky had thank you. And Licky had a comment which I think would be great to work out more in your response about real estate and housing being adapted in the long run. And both Tanya and Licky referred to long-term, short-term adaptation. So that's worth writing out a little bit just for us to capture, and we'll come back to the time scale over which we're talking about adaptation is absolutely critical, for sure. Oh, we're down to no time. I'm sorry, but one more thing I wanted to bring up from this Fournier article about the city is more than an analogy. It's really crucial, and it's worth reading when you read it yourselves again. He's criticizing the whole approach to modeling any kind of real life thing like an economy, our language, the way we use words, literature, living systems, whatever, cities in this case, by a model. A model meaning something you can write down in equations or draw sort of diagrams, or even describe using something as sophisticated as complexity science, let's say, okay? Any kind of theoretical construction, or a game, a video game, you know, is that the model is just going to be able to capture a very tiny sliver of all the messy, rich stuff that's happening. Like in his case, talking about the types of, what is it here? The urban social behavior, how people relate to one another, all the jealousies, aspirations, gossip, etc. that's happening, or also things we inherit from past generations, you know, the jokes and movies we got from before, all that, right? It's a lot more complex, he said, than even cross-species competition in the Amazon jungle. But just to underline that, he's not talking about the actual jungle. He's talking about the biological models of cross-species competition in the jungle. It's a model, okay? So then I agree with him. It is more complex. But the key thing is the idea of modeling itself has severe limits on what we can capture in the model. And he says part of it, and then he goes on and says, look, the kinds of models we use, it's still mechanical. We talk about information networks, IT, networks, computer systems. And this is what I'll come back to later on, is that they're very mechanical. They're very mechanical. They're 19th century, actually. They're kind of steampunk. So they're even more sparse than a biological model, a model of biology. And that captures our imagination. So we can't design out of that box very easily if we think about systems that way, okay? You want to have the last word, Licky? In your comment, you said something in chat.
Oh, all right. I was kind of echoing Tanya's points, the points with bicycles and cars. I got back from Nigeria, I got back from Lagos, and it was so hot, and I was like, I can't remember it being this hot. And then I was like, oh yeah, when I just get into the AC in class, I'll be fine. But then it begs to question, I mean, I don't think much can be done to change now. It begs to question, should humans really be building in a desert? Maybe there are really complex infrastructural problems, because those problems don't necessarily have solutions, because the assumptions, and like you said, the model is faulty in the first place. So if you keep trying to fix a faulty model, it's not going to work, because the assumption, the very premise upon which it's built is faulty. So I do think that there are some things that we cannot change because they already are, but I think it's a great point for us to think about as we reimagine future cities, or even the utility of cities. Just because they have emerged does not mean that we should retain them as the status quo. Maybe we would have more sustainable environments and living for people if we moved away to a more distributed settlement, which maybe looking at data was what worked in the first place. So I kind of think that emphasizes the point of this particular article, which is countering
system cities. System cities accepts cities as the norm. But yeah, those are just thoughts running through my mind.
A great place to finish today. So thanks so much, all of you, and I look forward to seeing you in the coming week. Don't forget, Friday is when we get the responses back on what's in infrastructure. Give some examples, okay? All right.
Yeah, actually, I had a quick question
Please,
with that.
Jacob.
So, I think you noted, at least for the Zoom call, to have like sources and whatnot. What are your expectations for these discussions?
Well, discussion versus you mean the
Assignment, yeah, the discussion board.
assignment. Well, what I'm looking for is evidence that you've read the readings, okay, that you got
Okay.
something from the readings. That's what I'm looking for, right? And that you can, and then the concrete question is give some examples, right? So that's original work. That's you know, you come up with some examples. And the reason I want people to be able to see each other's discussions so that, you know, you can do something, you know, that's not just what everybody else says, right? So that'll be what I'm looking for. In terms of length, a couple pages should be enough, you know, not long, should not take a lot of, it's not like a paper, okay? It's like a response note, okay? So if it does the job of saying, okay, I looked at this and this, here's what I say, it helps to be more precise in your citation of what you're drawing from, you know, from which article, what person, what, if you want to quote something, cut and paste, that's fine, you know, but, you know, be precise if you're going to make a reference. That should be enough. Is that enough? Okay, good. Looking forward to reading your responses. Take care. Bye-bye. See you.
Thank you. Nice to meet you all.
Thank you.
Thank you.
Thank you.